Good morning students. Today we are going to continue our topic and today we are going to finish our topic, that is Z test. So we have already deal with the Z test, what are different characteristics of the Z test. Today we are going to see the working procedure of the Z test and by means of solving an example. So what is a Z test? You already know that Z test can be defined as it is a deviation from the mean in a normal distribution curve and it is called relative or standard normal deviation. So that Z test is also said to be the standard normal deviation or the relative deviation and it is given by the symbol Z. So today we are going to see the working procedure of the Z test. So working procedure, so it is consisting of the first step. You know that even in the student test and rest of the significance test, we have to apply the first step, that is said to be the set the null hypothesis. So here also we are going to set the null hypothesis. Null hypothesis can be represented by means of HO. You know it. So we used to say that there is no significant difference between the sample mean and the population mean. So what do you assume first? We used to assume that there is no significant difference between the sample mean and population mean. So it can be written as XO, this is hypothesis, null hypothesis. We used to say that this is the mean. So there is no difference between the sample mean and the population mean. Consider mu is the population mean and X bar is the sample mean. So we used to say that there is no difference between the two, or this is equals to that, or sample mean is equals to the population mean. So next steps in the working procedure is a computation of the Z test. So before that one more steps we have to find out, that is at the same times when you used to set up the null hypothesis, we have to set up the alternative hypothesis also. So what will be the alternative hypothesis? That can be represented by means of H1. So H1 we used to say that there is a difference between the sample mean and the population mean. So how do we write it as? H1 is equal to X bar, alternative hypothesis can be presented by means of H1. So we used to say that there is a significant difference between the sample mean and the population mean. So this will be the alternative hypothesis. So it can be represented by means of alternative hypothesis can be represented by means of H1. So H1 can be written as, we used to say there is significant difference between the sample mean and the population mean. So this is the sample mean and this is the population mean. So we used to say there is a difference between the sample mean and the population mean. Next step is computation of the Z statistic. We have to compute the Z value. So after setting up the null hypothesis, we have to set the alternative hypothesis and then we have to calculate for the Z statistic. So in order to compute the Z statistic, there will be two methods. One example in which the SD is given. So when the standard deviation of population is known, then we have to apply a formula, that is SC of the X bar. SC means standard error of the X bar is equals to sigma by root n. So we can write it down that SE, standard error of the X bar, is equals to, here the standard deviation is already given. So that is sigma by root n. So we can find out the standard error of the mean by means of sigma by root n, and we know that we have to compute for the z test. So in order to compute the z test, z is equals to, we know that is a difference between the mean of the sample mean and the population mean. So it can be written as x bar minus mu by standard error of x bar into, this is the standard deviation, sigma. So this is how we have to calculate for the Z statistic where the SD of the population is known. But there is one case when the SD of population is not known. So if the SD value is already given, then we can find out the standard error of the mean by means of this formula. Z is equals to difference between the mean by standard error of the mean into the sigma. So what is n over here? What is n? N is the number of sample. So n is the sample. Next, what is sigma? Sigma, this is can be written as this way. Sigma is nothing but the standard deviation. And what is mu? Mu is equals to sample mean. Sample mean. So here this is sample mean, this is population mean. So in this way we have to calculate the Z test where the standard deviation of the population is known. But when a condition reach when the standard deviation of population is not known. So when the standard deviation of population is not known, let S be the standard deviation of the sample to calculate the standard error of the mean. Then the formula will be little bit different. So we can write down as SE, standard error of the mean, is equal to sigma, means standard deviation, by root n. This is a normal formula in order to find out the standard error. So Z can be written as Z is equals to x bar minus mu divided by standard error of the mean. Standard error of the mean, that is equals to x minus mu divided by s. So I already said that when the standard deviation of population is not known, जब हमें standard deviation of population पता नहीं रहता है, तब हमें S consider करना पड़ता है कि that may be the standard deviation. S will be the standard deviation of the sample. S हमने consider किया है. And then we have to calculate the standard error. So here it can be written as x minus mu root n by s. So in this way we have to calculate, here this is s by root n. So here this value s by root n comes over here and it becomes just opposite. Therefore the root n will goes over here and s will go below. So the z value can be calculated by this way when the standard deviation is not given. That is, z is equals to x minus mu into root n by s. Here when the standard deviation of population is given, then the formula will be this one. Z is equals to x bar minus mu divided by standard error of the mean into sigma. So this is the sigma or standard deviation. But when the standard deviation is not given, then the formula will be remains the same, only here instead of SE we have taken S. So when the standard deviation is not given, then the error or standard deviation can be taken as S. So S by root n. So root n will be the in the upper case and s will be in the lower case. So in this way we are going to calculate the z test when the standard deviation is given and when the standard deviation is not given. Next point will be the we have to find out the level of significance. So here the let the level of significance will be A. So consider A will be the level of significance. So in this way we have to calculate the value of Z. So we have to find the critical value of Z by means of computing inside the formula. And next last point, that is decision or conclusion making. So if the computed value of the Z, if the computed value of Z is less than the critical value ZA, this is level of significance, what will be the value of the Z? So if the calculated value is less than the given tabulated value, critical value of ZA at the level of significance, we used to accept the null hypothesis. Always consider that when the Z value is lower than the tabulated value or the significance value which is given in the table, if it is less than, then we used to say that we used to accept the hypothesis, null hypothesis. And if the calculated value of the Z, if this Z value, calculated value is greater than the given value of the significant value of the table, then we used to reject the null hypothesis and accept the alternative hypothesis. So always remember that if your calculated value is less, then we used to accept the hypothesis, and if your calculated value is more than the given value, then we used to reject the null hypothesis and we used to accept the alternative hypothesis. Now coming up to the example, we are going to solve an example. So the given example is the mean IQ of the sample of 1600 children. The mean IQ of sample of 1600 children was 99. It is likely that this was a random sample from a population with the mean IQ 100 and SD 15. So here we can see that the SD value is already given here. So first step in this example is that we have to set the null hypothesis. So what will be the null hypothesis? So what we can write out the null hypothesis is that sample has not been drawn from the population with mean IQ is equal to 100. So there is two IQ, mean IQ, that is one is 100 and another is 99. So we know that the sample n is equals to how much? 1600. So n is equal to the mean of IQ of sample of 1600 children, means this is the n, is the number of sample. What is x bar? Mean is given now. How much it was? 99. So the x bar is equals to 99. And it is said that it is likely that this was a random sample from a population. Another mean is given. What is the another mean? Mu. That is equals to 100. And what is standard deviation? Standard deviation is 15. So here we have given n, we are given x bar, we are given mu, we are given SD. So we have to just input inside the formula and find out the Z test. But before finding out the Z test, the step we have to follow the steps. That is null hypothesis. So what do we set the null hypothesis? The sample has not been drawn from the population with mean size 100. 100 IQ value में से sample size नहीं लिया गया है. So we have to put on the alternative hypothesis. Sample has been drawn from the population hypothesis. So alternative hypothesis just opposite of the null hypothesis. Now we are going to calculate the Z value. So here we know that n is equal to 1600, x bar is equals to 99, x bar, mean value. And mu is equals to, this is mu, mu is equals to 100 and SD is equals to 15. So we know that standard error is equals to standard deviation divided by root of n. That is equals to 15 divided by root of n. What is the n? N is nothing but this 1600. So 15 divided by 1600 will gives you 15 divided by 40. Square root of 1600 will be equals to 40. That will be equals to 0.375. So this is the standard error. Now we have to put inside the z value. So here we have to take the absolute of z. Always remember that's not only the z value but it is the absolute of z. That can be written as absolute of x bar minus mu divided by standard error of the mean. This is the formula. That will be equals to, what is x bar? That is equals to 99 minus 100. This is all absolute value divided by standard error of x. How much we got it as? 0.35. So 0.375. That is equals to minus 1 by 0.375. This is again the absolute value. That will be equals to absolute of 2.67. That will be equals to 2.67. So here we get the value, that is 2.67. 2.67, where the SD is given. Now the critical value. So critical value, since we know that ZA level, that ZA or the level of significance is not given, so we can take 0.05 as a significant value. So here in case of Z test, 3 values of Z or significant level of Z is given. That is 1% level of significance, that can be represented as ZA at 1%, 5% of significant level and 10% of significant level. So normally we used to take 5% of the significant level. So here we can say that ZA level of significance is not given. Either we have to find out at 1%, 10% or 5%. So if this level of significance is not given or you are not asked, then we have to take it as 0.05 level of significance. So normally in all cases we have taken 0.05 or 5% of the significance level. So here, since ZA is not given or the tabulated value of the Z is not given, at what level, significant level is not given, we are going to select it as 0.05. So the significant level is at 0.05. So significant level at the 0 point tabulated value is 1.96. So ZA at 0.05, it is equals to 1.96. And we know that our calculated value, Z value, is 2.67. So we know that our value, that is calculated value, is greater than the tabulated value of the Z. So we can say that if our calculated value is greater than the tabulated value, what we used to do? So here this condition is not satisfied, this condition is satisfied. If Z value, this condition is satisfied. So if Z value is greater than the critical value of Z, then we used to reject the null hypothesis. So what we are going to do? We are going to reject the null hypothesis. So here we are going to, you know that 2.67, this is the calculated value which is greater than the tabulated. What is the tabulated value? 1.96. So we can say that null hypothesis is rejected. Null hypothesis is rejected and alternative hypothesis is accepted. So what was the alternative hypothesis? Alternative hypothesis, there is a significant difference between the sample mean and the population mean. So that will be the conclusion. So we can say that key null hypothesis is rejected, and we can say that the sample has not been drawn from the population with the mean 100 and the standard deviation that is equals to 50. So with this we have completed the Z test. Thank you for watching.